Hello YouTube, Gadget Boy here. Welcome to another video. Sharp-eyed viewers may note a mild change in the topography of my desk here. I've added a border here, so I stopped doing things out of shot and you'll actually be able to see what I'm doing. Anyway, in this video we are going to autopsy this Siemens overload block. Now, an overload block is something that's used in motor control. It monitors the current that's coming into the circuit through the motor leads here, and if it's drawing too much current, it cuts the circuit and then the whole thing shuts off. I'll go into a little bit more detail. I keep saying that. Don't take shots every time I say I'm going into more detail in another video. Anyway, I'll go into detail in another video because it's actually a pretty neat concept. But the purpose of today is just to take this thing apart and figure out what happened to it. Earlier today in class, well, today for me, it'll be sometime next week for you guys, but earlier today in class, while we were working on our motor control labs, I departed to use the washroom, and when I came back, there was the smell of burnt electronics in the air, and yeah, that's still quite bad. I wish I could communicate that odor through YouTube, but I came back and there was this wonderful smell of destroyed electronics when I returned. And so I asked my instructor, hey, can I take that home and autopsy it on my channel? And he said, sure. So here we are. I have no idea of the topography on the inside of this thing. I don't know what kind of components it contains. So this is going to be as educational for me as it is for you. We're just going to take it apart and see what's inside. See if we can figure out what the mode of failure was, because the whole point of these is to prevent an overload in the motor circuit. And what we had was an overload so intense that it destroyed the overload block. So that's kind of interesting. So I'm just kind of investigating this thing here. I guess we'll figure out what that does in a second. Seeing if I can figure out how to take it apart. My instructor Billy said, hey, that's progress. Said that he had these apart before. Ooh, there's a lot of greasy, sooty stuff here. Give me a second here. I'm just gonna reach around behind me and grab one of those and kick my table and fall over the cat and do all sorts of things. But there's some sort of residue in here. It doesn't have a particular color, which is interesting. That smell I was mentioning earlier is getting really rather quite intense now. So I'm just going to keep investigating this. I'd like to not destroy it. Well, it's already been destroyed, but I'd like to leave it as intact as possible while taking it apart. Just because I think it might be interesting to try to leave behind for the future classes to have a look at a blown up overload block. Come on. You look like you should be coming out. Why aren't you coming out? Let's see. There's clearly a point of separation here that I can exploit. Oh, that happened. I can definitely see the heater coils are very blackened and sooty. So that's the heater coils are literally that. They're coils on the inside of the overload block here that I need a more delicate instrument here. They're heaters that bend a bimetallic strip, or they are themselves a bimetallic strip, and when they overheat, they trigger a contact that interrupts the circuit and stops whatever is causing the overload that's causing them to overheat. Let's see. This certainly is acting like it wants to come apart here. Ooh, that happened. Alright, let's... Oh, that smell is really quite noxious. I'll tell you guys what, I'm gonna go into time-lapse mode here so you don't have to listen to me try to figure out interesting stuff to say while I'm taking this apart. And, well, I'll see you on the other side of the time-lapse, hopefully after having successfully Okay, well, that took a considerable amount of violence, which I had predicted, but, wow. Okay, so, the carnage you see before you is what it took to open this thing up, and I think that may have been partially due to the fact that as the whatever circumstance caused this rather astonishingly bad failure, whatever circumstance led to that, kind of melted the plastic. Like, you can see all this crunchy black stuff here. That's all bits of the inside here. Let me see if I can get this to focus. Yeah, that's actually going to give you a fairly decent view there on the inside where the plastic is all melted. There's actually a cover on the back there that's supposed to come off nicely, but you can see here it had actually been melted into the case. So most of my troubles were because of the fact that the heat that this thing underwent during its overload there pretty much just welded the thing shut. That being said, I have no idea what happened to this thing. I have a theory, and that's borne out somewhat by the condition of this heater. So these are what we call the heaters, these things here. And you'll see that they are in progressively worse condition there. And these are bimetallic strips. And if you're pulling too much current through your motor, these will flex because the current that you're drawing through your motor goes through this coil here that's wrapped around that. and that's probably, I wouldn't quote me on this, but I'd be willing to wager that that's nichrome wire, which is used in heating elements. And that's going to heat up. That's got a fairly high resistance, so it's going to generate heat. And this bar here bends over. When that bar bends over, I wish I'd shown you the top of this before it all fell out, but those bars push these things, which were sitting in the top. They push this little arm. That little arm pushes that little thing over, and then you're in a overload condition. And you can see when that gets pushed over by that arm, it locks. The contacts for the low voltage side of the circuit open, and the control side of the circuit, which runs on low voltage, cuts out and the motor stops running. And then you have to come over here and hit your little reset button there, and it will re-enable the circuit for you. So that's basically how that system works. Now, what I think happened is, well, you see this? This was line 2 of the 3-phase system. And as you can see, the nichrome wire has just, it's actually crumbly. I hadn't thought about this until just now, but the byproducts of this overload probably aren't safe to be touching or breathing or being anywhere in the same province as, so I'm probably going to get like space cancer or something, but oh well, science. So you can see that this just, it was obliterated by the amount of current going through it. I don't know if maybe they accidentally ran 2 phases through one of these heaters, but that just, it immolated. There's ash and dust, and that's the source of that raunchy smell. And this was L3, and you can see L3 is also, it's pretty well cooked too. And I'm fairly confident that that heat came from itself, not from proximity to that one. So there was something going wrong with L3 as well. And yet L1 is absolutely pristine. There's absolutely no damage in L1. So whatever happened in L1 and L2. Maybe they shorted across each other, but whatever happened, it was so intense, and this thing burnt so fast that the bimetallic strips didn't have time to cut out the control circuit, and it just died horribly. It was at least quick. So there you have it. That's the autopsy. That's one of the most spectacular autopsies. Well, it's only the second autopsy, so I can't really say it's the most spectacular. I'm sure I'll do more spectacular autopsies down the line. But to date, that is the most spectacular autopsy I've ever done, actually in my life, of any electronic component that's failed, let alone the channel. So, hope you enjoyed watching me struggle around with that. I probably won't subject you guys to the whole time lapse. That took about 45 minutes for me to figure out how to take it apart. So I'll probably just cut out parts of the time lapse, or just play it at warp 10, and you guys can see me struggle with it. So there you have it. Thanks for watching the video. If you liked it, do that thing you do when you like videos. I'm still trying to get my 100 subscribers so that I can actually name my channel something other than QXY capital R2FG, whatever the heck the default, URLs are. Also, there's a link to my Patreon. It's going to be down in this direction. I'll put an annotation somewhere over here too. I've set up a Patreon to help had both the expenses of doing these videos and my own living expenses, you can go on to my Patreon for a little bit more information on that. Even a dollar here and there helps with that. So yeah, give that a visit, share and like with your friends, and I'll see you in the next video.